Hey time travelers, I'm gonna be filling you in for the Panopto video. This is gonna be 4.58. I'm not gonna write down the whole thing, but I will make a diagram and I'll walk through my work because this one was really complicated the way I did it. I'm more than sure that there is a way that I'm not seeing to do it because I don't think that this should be expected of you guys, but I might be wrong. So we know that it accelerates for 0.7 meters and it's 2 meters off the ground. 2 meters off the ground. And we know from this point it's in projectile motion and it goes a length of 62 meters and it depresses by 2 meters. We know that it's released at an angle of 30 degrees. And that's kind of all the information that we're given. So we should, let's write down what we know. We know the change in x, which is 62 meters. We know the change in y, which is 2 meters. And we know the angle that we are shot off at, which is 30 degrees. And we want to know acceleration across this. But in order to do that, the easiest way is going to say like v final squared is equal to v initial squared plus 2a change in x, where your a is this and your final velocity is your initial velocity here. So we want the initial velocity for the projectile motion. The equations which I used were change in y is equal to v naught in the y direction. So we're going to say v naught in the y direction is equal to v naught sine of theta. So we're just going to place that in. Sine of theta, and that's going to be times time plus 1/2 acceleration times squared. Now, what's difficult about this is that we are not given time. So we can give time in terms of these things. So we can say change in x is equal to velocity in the x direction, which is going to be v naught cosine of theta times time. So we can rearrange for time, and we can say that time is equal to change in x over velocity times cosine. We can't really do any rearranging yet, so we're just going to plug / substitute. So we have our change in y is equal to theta times change over sine theta. So we're going to say these cancel, and we're going to say sine over cosine is tangent of theta. So we're going to take this whole term, and we're going to turn it into tangent theta times change in x. I'll put that change in x out front. And then we have the second term, which is 1/2 acceleration. So acceleration is g because we're in the y component. So g over 2 times t squared. So this is going to be x over so what this means is we need our change in velocity. So this is going to be some pretty tricky algebra. So we're going to do it one step at a time. So and take the g over 2, multiply it by both sides, and take the square root. So 2 over e times and what we can do then is we can take the inverse. Okay, so this is what I got as a formula for v naught. Note that there are other mathematical ways to represent this. when I did it the first time, this is what I got. It's mathematically equivalent, and we can plug it into the calculator. That's what I got in it as an answer. Of course, there's a lot of room for error, but that's why I did it twice. Yes, so this is going to be your V naught, and so that is directly coming across. So it's not in the y direction. If it was in the y direction, it would have the sign attached to it. And so now with your V naught, you can say that and you know that V initial squared is 0 because presumably the javelin is starting from it. Sorry, this is from throw because we know that V final in throw is equal to V initial for projectile motion. So we can say that we can rearrange for A. We can say A is equal to E final for change in X. And so that's going to be 25.78 squared over 2 times 0.75 because it's this change in X. I got 474 meters per second squared. That doesn't make a ton of sense, but 25 meters per second does make sense as a throw-off point. So I'm just gonna say she's very strong and that the javelin is very light. So we can say FMA, like force equals mass times acceleration. Her force could be like 100 newtons if the javelin is like 0.25 kilograms, for example. If that was 400, which that's some really generous rounding. I'll check with Brian if this is right, but that is kind of all that I have for this one. I have a funny feeling it's wrong, but I think even just sort of the methodology might be helpful. But yes, I will check with him. And fingers crossed the Panopto video just loads. Okay. Best of luck, time travelers. Know that even if it's confusing, trust the process and know that you got it. I believe in you.